20 weeks. So this is not something you'd ever hear me saying, but because of the love for the library, I do want to say that I take it as my personal duty to make sure that that all questions get answered and we all learn for the next 20 weeks. So that's the reason that we're here today. And the one person who's been at the center of it all and the center of pretty much all my learnings has been Jeremy Howard. We all know of him as a data scientist, researcher, developer, educator, and an entrepreneur. Jeremy is also was the founding CEO of Analytic, which was the first company to apply deep learning to medicine, and was selected as one of the world's top 50 smartest companies by MIT Tech Review for 2 years in a row. He was the president and chief scientist of data science platform that we all love today, Kaggle. And he was top ranked. He was ranked #1 for 2 years in a row when he was doing and working with Kaggle. And he was also the founding CEO of 2 very successful Australian startups, Fastmail and Optimal Decisions Group. And before that, he spent 8 years in management consulting at McKinsey & Co. and AT&T. Jeremy has had not just me personally, but many others that I know. He's had life-changing impact on my life and various others' lives through the work that he's done. So everybody, please welcome Jeremy. And thanks, Jeremy, for joining us. You should be able to share your screen.
Thank you, Amma. It's a great pleasure to be here. No, the host is disabled participant screen sharing. So somebody needs to press a magic button to let me share my screen.
Angelika, is that something you could help me with?
Yes, I believe it says screen sharing is enabled for you, but let me try again. All right, could you try again now, please?
That's fine now, thank you.
Excellent.
Okay, hi everybody. As Aman said, this study group is about this book, Deep Learning for Coders with FastAI and PyTorch. As Aman said, it's available both as a actual paper book or as a Kindle book or as a series of Jupyter notebooks on GitHub. They're actually identical books, so you can happily switch from one to the other. So the content is exactly the same. So if you're using the free version, you're not missing out on anything other than some nice formatting and indexes and stuff like that. Even if you're working through the paper book, we highly recommend that you also have the notebooks open, because this course is really designed around experimenting and playing with code yourself. So I'm just going to talk a little bit about some of the things that people have found have helped make them be successful in this course. Hundreds of thousands of people over the last 4 or 5 years have now attempted the FastAI course. We create a new version most years. I think we're up to version 4 at the moment. But to be honest, when we look at our YouTube analytics, most people don't stick with it. Most people do the first lesson or 2 and then stop. That's not necessarily a problem. If your goal is just to get a kind of vague idea of what deep learning is and what it can do, the first lesson or 2 is actually a pretty good way to do that. But if you're coming here today thinking, I want to go through the entire book or all 20 of them, then you recognize that you're making a commitment to yourself that most people actually do not keep. And so try to figure out how you're going to be somebody who keeps that commitment. There's a huge difference, I find, between people who finish the book and those who don't. a lot of people get distracted on the journey, and which is fine, but just make sure you come back to it. So the fact that Aman has started this group is a great way to make sure that you at least, commit to yourself that you're going to turn up every week. And one of the challenges is that over the next 20 weeks, at some point, you'll probably get a cold, or your daughter will break her leg, or you'll have a really busy period at work, or something will happen. And one of the main reasons that people fail to keep the commitments they make to themselves is that something comes along and distracts them. And that can be quite, upsetting to realize that something has gotten in the way. The key thing is just to be easy on yourself and come back and keep going anyway. So if you miss a couple of weeks because of something, no problem. Just make sure that you come back and keep working through it. And that would be obviously much better than giving up and never coming back. This is what the GitHub repo looks like. Each chapter of the book is one notebook, and they're in order of the numbers here. So we actually built something called Fastbook that automatically converts Jupyter notebooks into a book. So that's why you can be sure that the book and the notebooks are identical. As well as the book, both the free and the O'Reilly versions, there's also an online course. That course is available at course.fast.ai. Course.fast.ai. And what you'll find is that there's a section here of lessons, 8 lessons, and those 8 lessons cover approximately the first half of the book. So it's often people learn best when they have kind of multiple modes of learning going on. So I would strongly suggest that in addition to reading the chapters, that you also look at the videos, at least do it for the first couple and see if you find that helpful. They do have the same information. On the whole, the book will probably have a little bit more information, but they're presented in somewhat different ways, and it might help your brain to take it in, to see it coming in through different modalities. So this is from a podcast from Sanya Hamputani, who interviewed Christine McClavey-Payne. Christine is one of our terrific alumni who have gone on and told us about what she's been up to. And after a lot of hard work, and one of the things she did was completing both parts 1 and 2 of the FastAI course, she was selected as a resident by OpenAI. And she went on to become a full-time deep learning researcher at OpenAI. And she mentions here that one of the most useful pieces of advice that she got was something I told her, which is to try to create at least one really great project. It's great to try lots of things, and you should try to make sure that every chapter of the book we come across, you create something, create some kind of project, however small or silly it is, or maybe it's just a direct copy of something else you found. But I suggest you also start to try to polish off something really well. And so polishing off something really well means to create really good documentation about it, really nice interface for it, deal with all those little bugs, make it as good as you can get it, because it's in the process of making something really great there's a couple of benefits. The first is that's the thing that makes you have to deeply understand what it is you're working with, so you can make all those little things just so. And it's also the thing that's going to make the biggest difference to your opportunities on the job circuit, because it's something that will be at the heart of your portfolio. It's kind of your capstone project. So I suggest that you also commit to yourself at this initial point that you are going to, during the next 20 weeks, work towards creating and really finishing a project. One of the things that's really, really important for making a success of Fastbook is being pretty good at coding, and specifically pretty good at Python coding. Even if you haven't coded in Python before, but you've coded in another language a reasonable amount, you'll find Python pretty easy to get going with. But if you don't feel super comfortable with coding, a good place to start would be Harvard CS50, which is a free online course. It's definitely going to make Fastbook much more intense for you than it would be for somebody who already is comfortable coding, but it is possible if you really invest hard. It is possible to kind of pick up coding as you go through the book. But yeah, be ready to really invest a lot of time and use other resources. So CS50 is a good place to start. Radek Osmalski, who I'm about to tell you more about, has this concept of a four-legged table of the things you'll need to know to get through Fastbook well. And they are a good understanding of code concepts, a good understanding of how to use your editor, a good understanding of Git, and a good understanding of the whole SSH and Linux environment. These are things which, even if you studied computer science, you may not have ever really learned very well. If that's you, then the MIT course called The Missing Semester of Your CS Education would be a great place to go, because it's going to teach you about these tools of the trade. And just like a builder is going to want to be very familiar with how to use a drill and a hammer and a level and so forth, as a builder of code, because that's the thing we use to create models, you're going to need to be really familiar with your tools. And I find nearly everybody I know who's very good at applied deep learning, when I watch them work, they zip through their editor really quickly. They're good at using their version control. They can SSH into a Linux box and zip through looking at files, stuff like that. So that is something definitely worth investing time in, and it'll pay back many times over through the rest of your career. So what do you do with a chapter or a lesson of the course? So you watch the lecture or read the chapter of the book, or both. And then you just go in and open up the notebook and run it, execute each cell of that notebook. And then as you run it, try to ask yourself some questions around what would happen if. So try and change some of those lines of code in the notebook, just in small ways, to try to kind of get a sense of what if. And the more you can experiment, the better, particularly if your experiments fail. If they give you a syntax error, or they give you a zero result or an all black picture, these are all really useful things because they tell you about things that your understanding of how you thought things work wasn't quite how things worked. And then debugging is a really great way to learn more about what's really going on. So then try to reproduce as much of the notebook as you can from scratch. That's quite challenging to do, particularly if you've only read the chapter once or watched the lecture once. So expect to be popping back and forth between the book and your screen, but try to actually type it in yourself. Try not to peek too much. Try to really think about what it is that you're writing and why, so that you can actually create your own version of the notebook, or at least the major parts of it. So where the rubber really hits the road is then to repeat the entire process that was in the chapter on a different data set. And that can be a data set that you download yourself, or it could be a data set that you curate yourself, or it could be a data set that's pre-existing that you download. And you'll find there's just going to be a bunch of little differences in the process. And so it's in that process that you're going to really test your understanding of what you learned. So I mentioned I'd say more about Radek Osmalski, and specifically I'm going to mention his book. So Radek is a student of FastAI who has recently published this book called Meta Learning, which, oh, my keyboard is out of batteries. Let me try over here. Yeah, Radek Meta, oh, there it is. So you find it here, Gumroad. I can pop that in the chat. Chat. Yeah. And so Radek somebody who started out with not knowing how to code and not very happy in his job, and decided he wanted to do AI, and he's been fantastically successful at that. He's actually a Kaggle competition winner, which makes him one of the top handful of people in the world. And he has had a couple of extremely exclusive jobs in AI, including currently he is trying to decode animal speech, which is quite amazing. And so Radek's been kind enough to write down his learnings along the way. And I already mentioned some of those learnings in the four-legged table bit, but for more, check out this lesson 0, which I'll pop in the chat. It's not the chat, that's the chat. There we go. Which includes some of the slides. Today I'm giving actually from that lesson 0, but there's a bit more information, particularly from this book. One of the things I like in his book is he describes his failed attempts at doing FastAI, which basically involved accidentally listening to all those gatekeepers who claim that you have to start with the math foundations, calculus, linear algebra, probability theory. So Radek spent time learning calculus, which was very interesting. But then discovered that some of the advanced calculus required understanding construction of real numbers. So started reading a book about that. Then discovered that actually that was for real analysis, and then to understand real analysis properly, you have to actually deeply understand set theory, and so on and so forth. And this is a really common thing we hear, is that people try to learn to build useful deep learning models, but all they actually do is they spend years learning about theory. Theory is can be somewhat useful if you learn the right theory at the right time, but the right time is not before your first lesson. The right time to start training deep learning models is when you start learning, and then you can learn about theory as you start understanding better what's actually required to build effective models. And so this is the way FastAI does it. At first, if you're used to a bottom-up academic approach of learning, you may even find it a little frustrating that you're using things that have not been fully explained. But if you think about it, if you use Microsoft Word, for example, or Google Docs or whatever, and you start typing things into a computer, do you really know how every one of those pixels is being turned on? Do you fully understand what's happening inside your CPU? Do you really understand how things are moving over your PCI bus? Do you fully understand all of the messages in your operating system's messaging system? Probably not, right? It's fine to use tools and then to gradually dig deeper and deeper into them. If you finish the book, you will end up rewriting an entire ResNet from scratch, batch norm from scratch, a data loader from scratch, stochastic gradient descent from scratch, and you actually start doing it pretty soon. So you'll actually write your own stochastic gradient descent optimizer in chapter 4. So, be patient, but really, really try to focus on actually building useful things as soon as you can, because digging into theory is just a great way of kind of procrastinating actually doing deep learning. So this is from Radek's book. As I mentioned, you really need to become a pretty good coder to become a pretty good deep learning practitioner. And the only way to become a good coder is to read and write code. So I spend personally many hours every day reading and writing code. If you're going through a whole day without reading and writing code, then you're not really spending that day actually practicing your craft of becoming a better coder. And the more you can read code in different styles to what you're used to, and write code using different libraries to what you've tried before, and so forth, the more that's the deliberate practice, which allows people to achieve mastery. One of the most important things that you're going to be talking about in chapter 1 is creating a validation set. The difference between, or our key difference between normal programming and machine learning, including deep learning, is that in machine learning, it's all about having your computer be able to answer questions that are different to the input data that you taught it with. You need to know that it can handle data that it's never seen before. And the only way to do that is with something called a validation set, which is a data set consisting of data which your model never gets to see as it's learning. It turns out that building a good validation set is deceptively tricky, and most people get it wrong. People that win Kaggle competitions nearly always say that one of the best skills is being really good at creating validation sets. And so you'll start reading about how to create validation sets right from lesson 1. And that's something you should really spend time thinking about. And there's a great blog post here from my co-founder, Rachel Thomas, on how and why to create a good validation set. Okay, so that's the end of my little presentation of some tips about what Fastbook is and things that might help you succeed in your 20-week journey. So good luck, everybody.
I just realized I was in mute. Thank you, Jeremy. I think I want to say, as I've personally benefited from the learnings that Jeremy has mentioned. For example, committing to the 20 weeks. I think that's really important for us as a group to commit to 20 weeks. Lots of projects, coding, failed experiments, even about we go deeper gradually and read and write code. So these are the main learnings that I've actually built the foundations on top of. And in this section, I just want to quickly go through with everyone on what the next 20 weeks are going to look like and how we're going to have, how is the every session of Fastbook reading going to look like for the next 20 weeks. So there's, with Fastbook, there's two versions of Fastbook inside the repo. So if I go into the repo, there's this whole Fastbook that Jeremy mentioned are the 20 chapters. But there's also the clean version. So if we go into the clean version, there's also a clean version. And the main difference between the clean version and the book itself is that the clean version just consists of code. So on the left, we have, this is the actual book and the actual Jupyter notebooks. These are with prose. And on the right, we have the clean version, which is without prose. So you can see how going through the whole chapter, if we do decide, because we want to also be conscious of time every week, and we want to commit to finishing, these chapters. So if we go through the whole chapter, there's a lot of content for us to cover every week. And something that we're going to do as a group, we're going to be sitting in the middle. So I'm going to personally go in every week I'm going to read every chapter every week, and I'm going to convert the with prose into without prose, but with explanations and examples. So we're going to actually be somewhere in the middle where there's going to be enough explanation for everything that's on the right. So you'll understand every bit of code, you'll understand all context, but it will give you enough and pretty much almost everything to then go back and read the book. And in case you miss out, that's going to be okay, and you can come back next week and we can continue from there. But it is expected that you do go back and read the book to get the maximum benefit. Every chapter in the book, as Jeremy mentioned, it's important to then think of questions when you do a chapter. And it's important to think. It's important to test the understanding. And I really love this book for the questionnaire that comes at the end of it. So when you read a chapter, there's always a questionnaire towards the end. And as a group, we're going to be discussing every bit, every question, and we're going to be answering all the questions that are mentioned here gradually over week by week. We're going to be using the Weights and Biases community Slack. So that's 1db.me/Slack. We will send an email out to all participants, and we can be a part of this Slack, and we'll be using this to communicate with each other, to ask questions, and general communication on projects. This is something I do want to share. This is a snippet from my journey, and my journey was built on top of Jeremy's learnings. And what Jeremy said, I followed it really well. And I think that has really helped me in my life. So for example, the one thing I'm going to say is we want to have interaction within us. We want to have a lot of interaction between us as a group. And I want to promote that. So, and it doesn't have to be a big thing. My first ever comment on a FastAI forums. So FastAI forums, if I go to the forums.fast.ai, there's a whole multitude of, there's a lot of stuff and there's a lot of activity for deep learning practitioners who also want to learn deep learning. And there's lots of questions and there's lots of things. I really like the share your work here thread where everybody who's starting out shares a lot of projects that they're doing. And these don't have to be big projects. They can be small projects. So we'll be doing, as part of this, we'll be talking to each other a lot. We'll be interacting with each other a lot. And I just want to mention, for example, my first ever comment was a thanks, and that's it, a plain simple thanks. But doing so and just writing something like this, like a hi or a thanks, got me going. It really, I felt like I'm part of the community, and the next time I answered a question, and straight away, the next thing within the first month of joining, I was interested in forming a study group at Sydney. So I really want us to think of it this way, and I really want us as a group to also form study groups based on the time zones that we're in. And we'll be doing that this first week before we get started next week. The one on the right is again, when I say I followed Jeremy's advice, I really did, and it got me to where I am today. So this is just, this was a thread again on the FastAI forums in 2019. And I said something that has helped me with FastAI has been to re-implement each notebook, take it by the week instead of being in a rush to complete the course. So I really wanted to finish. As Jeremy mentioned, it's important that we finish and we commit to those 20 weeks. I take FastAI as a marathon and not a sprint, and make sure that I finish strong. And 2 years after, this is again in June 2019, and 2 years after, I still live by these words. And I'm so happy that even 2 years ago, I was thinking along these lines, because 2 years ago, what I was doing and starting out with my journey, that really helped me into learning a lot of things like implementing ResNet from scratch, and starting from somebody who didn't know deep learning to going week by week, going deeper into the content. So write self-notes, do research on things that are hard to understand. I'm spending lots of time writing code and digging into the FastAI source code, as Jeremy also mentioned. We want to be spending lots of time reading and writing code.
And so one thing I should mention is, I think for people watching, you know, you might imagine that people like Radek and Aman, who have successfully built careers as deep learning researchers, are uniquely special and that you can't possibly do what they do. But actually, the vast majority of people I've seen on the forums and the Discord and so forth who do the things that Arman is talking about and that Radek writes about, like it's very obvious. I can see them doing it because you see their artifacts as they post on the forum, they create blog posts and so forth. The vast majority of people that do that today have, significant expertise in the field and generally have jobs in the field or are applying deep learning in interesting ways. So I think, in terms of your self-confidence, it's important to believe that you're somebody that can do this. But as Aman says, it does take time, and that means that tenacity is really important.
Thank you, Jeremy. Just to add on top, I did start as a quality analyst, so most of my job was testing, and it wasn't even anything related to software engineering or coding. But thanks to the course and thanks to the week-by-week learning, it has really helped me understand deeper every day. So that's our approach is going to be. But one thing I'm really excited to present is we'll also be joined as part of this journey. We'll be joined by Zachary Muller. We'll be joined by Tanishq Abraham, and we'll also be joined by Sayam. So they're also three people who I've met through the FastAI forums and through the community, and they're also very much into FastAI and field, just as passionate about the library. So Zach is a machine learning engineer at Novetta. FastAI was the only course and ML course that he ever did. And built on top of that, he started with a walk with FastAI, which really adds more on the FastAI course. So he started doing things with object detection or other things that he wanted to try. And FastAI library really enables those sort of experiments and those sort of projects. So he'll be joining us for guest lectures towards the end.
Zach should probably be thanking his dad for this, because he told me that he was studying marine biology, and his dad was like, "You should do coding and you should do AI." And Zach was like, "Nah, that sounds stupid." And eventually his dad convinced him to try it once, and he was like, "Oh, actually, that's kind of fun." I thought that was an interesting story. So he was going in a very different direction.
Definitely. And then we see him today, he's doing the FastDebug project, and he spent about 33 days in the forums. So you can see, I guess, through these examples, we can see that being active and being actually taking this and doing this seriously can help us a lot. Thanks, Jeremy. With Sayam, he's the host of the Shydime's Data Science podcast, and he's interviewed hundreds of practitioners, and then he's also interviewed Jeremy. So do feel free to check it out. He's also an ML engineer and AI content creator at H2AI. He's a Kaggle discussions master, and he's an active blogger with over 1.5 million views across various blogs. And he's with us today on the chat.
And he also represents this this idea of tenacity. He set out to, I can't remember exactly what the statistics were, but to post a certain number of podcasts every week for I don't know, a year or something, and he totally stuck to it, and in the process built a very significant audience. And so he's definitely somebody who, when he says, "I'm going to do X," I know that X will be done, and that's really cool to see how much success he's had.
Absolutely. And they were also joined by Tanishq Abraham. He's one of our youngest, but he's also one of the most talented people that I know and I've met through the FastAI forums. So Tanishq is only 18 now. It was
18 now, I think.
believe. Yeah, it was his birthday a day or two ago. He's an 18-year-old biomedical engineering PhD candidate at University of California. So I believe he's in his third year of PhD. His journey also began, like many of us, by taking the FastAI course back in 2019. And he's been a frequent contributor to the library and the forums. He's also a Kaggle notebooks and discussion master, and he's written now packages like Zach has built a walk with FastAI. Tanishq has also worked on the UPIT package, which is an image-to-image translation built using the FastAI tools.
He's also been a fantastic researcher, by the way, and actually worked with us on some of our medical AI research.
Thank you. And I'm really excited that with all of them, Zach, Sanyam, and Tanish will be around, and we'll be doing guest lectures from them on their projects, and we can hear from them on their journeys. So thanks, guys, for being a part of this. Really, really appreciate that. Cool. Now we're in conversation with Jeremy, which is basically me taking advantage of Jeremy being on the show, because I've always had these questions to ask and never got the opportunity. But I thought, okay, today's my day, and I'm going to ask a question. So Jeremy, something that really amazes me, and really, it's when you see things like this, it's like inspirational and motivational at a different level. We saw Masks for All movement. It's active now as well, and we saw you begin the Masks for All movement, which got traction from the president of Czech. The Czech Republic went from 100% mask usage from 0 in 10 days. The Mask for All movement was mentioned in various newspapers like CNN, New York Times, Guardian. Jeremy also presented the paper that he wrote with 19 authors and 84 references on the effectiveness of masks, and it was presented at the WHO guideline development group. And I believe, Jeremy, you also worked with US Senators and Michael Bennett and Sen Toomey. And most importantly, I mean, this is a project that helped save a lot of lives, and it really became a trend all over the world to wear masks. And not just that, we also see, Jeremy, like just in the past 2 weeks, something I was really amazed to see, that apart from the Fast AI and apart from all the work that he does in the open source world, I saw an article from Jeremy in the Sydney Morning Herald, which was, it's a race, and fighting for vaccines is crucial. Jeremy attended the Queensland AI Hub, and he's also involved in the practical where the Fast AI course is running from 25th May to 27th July, and I'm also part of this. But that's not it. We see Jeremy also gave a talk at the Queensland University of Technology, which was only 2 days ago, with Rachel Thomas, who's also the co-founder of Fast AI. Sorry, there's more. We also see him active on Discord if I'm around and asking questions. And this was somebody asking about, this was a basic question. And sorry to point out, I don't want to point out anybody on the question, but just, somebody was asking about PDP and set trace, and Jeremy was there to the rescue, and he was there to point resources. And he's also answered many of my questions. And as someone, when you're beginning your journey and you see Jeremy answering a question, you're like, oh, Jeremy really found the time to do that. I mean, he really is around to answer these basic questions. And finally, there's also these various projects in the Fast AI. There's like NBDev, Fast Pages, Fastbook, Fast AI, Fast Score, and there's other projects. And these are just the visible ones. Like, these are just the ones I could find in the past few days that I saw Jeremy has been a part of. And I'm sure there's other life responsibilities. So Jeremy, really curious on how do you find the time, and how do you end up building such cool things, and really interested to know.
Oh yeah, I mean, it's been a busy week, I must admit. Yeah, I did have a few other talks I gave as well, and I'm writing another article for USA Today at the moment. The thing is, though, that I spend I'm very slow. Like, that's something people are surprised by when they work with me, is how slow I am. I'm not in a big hurry, but I do spend a lot of time kind of meta researching and meta learning, which is like learning how to learn and learning how to research and learning how to work. I think the main thing I've done, which I don't know of anybody else who's done anywhere, is to try to average at spending at least 50% of my time every day learning and practicing something new. So I've been doing that since I was about 18. That could be just like a new API online, or a new library, or a new programming language, or whatever. And the thing about that almost everybody I work with hates me doing that, because it always seems like I'm spending time doing something which is not the thing I'm meant to be doing with the person I'm working with. But at the same time, it you know, it builds in this really multiplicative way. So all these tools and languages and stuff that I'm learning all work together so that I do find I can kind of whip things out more quickly than most people I know. And I also find that I kind of end up with a lot of kind of useful knowledge so that I can kind of read papers and stuff like that in lots of areas. You know, so for example, recently one of my friends wrote a paper about the spike protein in COVID, which was being misunderstood, and the anti-vax community had really taken to it, and Alex Jones was talking about it. And so I spent a week learning about spike proteins and vaccines and so forth, and ended up writing a paper with my friend about vaccine safety and vaccine efficacy, and specifically focused on the role of the spike protein, which is, you know, something I don't know anything about, but I think, you know, when you decide to spend your time focused on learning something new, and particularly the more time you spend learning new things, the easier it gets. And so even though this was a totally new field for me, I found it was all just putting together stuff that was reasonably familiar. Second thing I'd say is I think it's really useful to realize that basically nobody in history has shown the ability to have more than 4 hours a day of creative, productive work. So you should try really hard to make sure that you get those 4 hours as many days as you can. Don't expect more, but really value those 4 hours and decide when those 4 hours are, and yeah, make the best of them you can. Don't start, you know, reading Facebook or comments or getting distracted. You know, this is your time of creative work. So it could be that you're writing a blog post, or you're writing code, or you're doing some kind of deliberate practice. Something that really helps you get the most out of those 4 hours is being in good physical shape. So definitely, you know, half an hour to an hour of intense physical exercise each day is good. You can, you know, we got a lot of practice with learning how to do that inside because we had the lockdown in California and the wildfires. And so you can do high intensity training workouts, you know, Tabata training, stuff like that. And so if you sleep well and exercise well, yeah, you know, really try to find that 4 hours. I think that helps a lot. One thing that helps find your 4 hours each day is to try to block time for doing things. So if you need to have some meetings, decide how many hours a week you're prepared to have meetings, and then set aside the hours each day that you're prepared to have meetings. So for me, I generally set aside either all of or part of each Friday for meetings. And so I use Calendly, which is the thing that lets people book meetings with me. And so I just show that as being my free time. And so then the rest of the time is not meetings, and it means I can focus. One thing Richard Feynman talked about, which I really agree with, is that it really helps if you bring joy to your work, and, you know, follow things that are interesting to you. So I do basically no medium-term planning at all, because that always feels like it sucks the joy out of things. I do long-term planning of like, what would I like to do in the next 10 to 20 years? I do short-term planning of what do I want to do in the next 1 to 2 days. But if people are like, what's your plan for the next month? I never have any idea, because I really want to have that ability to like find out what's the thing that really gets me excited right now. And so as a result, I find the vast majority of the time, the work I'm doing is stuff which I am deeply passionate about and excited about. Sometimes I don't enjoy it. I mean, most obviously the Masks for All stuff, I didn't enjoy any of that at all. I don't like, you know, politics and advocacy and honestly, I don't like masks. They're boring. They're uncomfortable. They're, but that was a case where it felt like a life and death situation. So I didn't need any more motivation than that, which was to, work hard on that every day, because every day that we hadn't succeeded in getting that message out was another day that we were getting more exponential growth of COVID cases. But on the whole, the vast majority of the things I enjoy a lot. And if it's something which doesn't seem that enjoyable, I will find a way to do it that is enjoyable and that I learn something new, even if it's slower. So I'll if it's some kind of tedious kind of admin exercise, I'll try and find some way to automate it, or make it fun. The other thing I try to do is to make everything extremely high leverage. So I almost never do a talk that's not recorded. Anytime I have a recorded talk, I'll put it on YouTube and try and make sure it's interesting and useful, and that I create the best possible Twitter thread I can to advertise it. If I'm going to write something for, a student, I will write it as a blog post and try to make it as good as possible, so I can hopefully get 100,000 people reading it. I find a lot of people do stuff in really low leverage, low scale ways, and I always feel that's pretty wasteful. If you're a professor teaching, a course to 50 students, I find most professors focus entirely on those 50 students. But if you put it online, you very quickly find you've got 50,000 students. And so that's just so much more exciting to be able to influence 1,000 times more people, but you can't physically see them. But for me, when I teach, I'm focusing on the 50,000 people I can't see rather than the 50 people I can see.
Thank you so very much, Jeremy. There's so much advice, and there's so much good advice, and there's so much learnings in just everything that you've mentioned and everything that you do. We as a community are really grateful to the work that you do, and you push out and make it open source. So thanks very much for that. We'll also go into the questions. So as I said, the site for this, we're going into the AMA with Jeremy now, and it's 1db.me/Jeremy. I'll just post it in the chat. So let's go and have a look if there's any questions here. I shouldn't have to refresh, but there's quite a few questions. Cool, this is the tough work. We'll try and get through all of them. I can't promise, but we're definitely going to try. What advice would you give question from Hrutik? What advice would you give an undergraduate computer science student who aspires to be a researcher in the field of artificial intelligence?
Do you mind zooming in a little bit, Aman?
Yeah.
Thanks.
Is that better?
Where I can read it. Yeah, that's lovely. Okay, what advice would you give to an undergraduate computer science student who aspires to be a researcher in the field of AI? It's a bit generic, so it's hard to give super general advice. I would say I would replace the words artificial intelligence there with deep learning, because deep learning is at the heart of nearly all of the really big advances in modern artificial intelligence. I think, if you want to be a researcher in AI, I guess the question is why? What's the purpose you want to be a researcher, and focus on that. So if it's just that you think, deep learning is an interesting field and you'd like to do more with it, then I would say you'll probably get more pleasure out of, working in a startup or something like that, where your work is being directly applied. A lot of research in academia is kind of dull. Academia really rewards the wrong kinds of things, which it doesn't reward innovation. It really rewards sticking to a kind of an area of research that everybody's familiar with, so that you get cited and accepted into conferences. I think everything we talked about in terms of being good at getting through Fastbook applies to this as well. You definitely want to be a good coder. You should really try to implement things. if you really do want to be an academic researcher in deep learning, to get published papers that are influential, you actually need to write code that implements those things effectively and gets good results. And then, yeah, other than that, I'd say, just like I said, to read lots of code, I'd also say read lots of papers and then re-implement them yourself from scratch. And remember, the people who wrote that paper have probably made lots of stupid mistakes. So read it with that assumption and try to find out, like, think about, like, what are the other ways that they could have done things? And then if you're not sure why they didn't do it that other way, try it that other way and see if you can get better results than they did. And now you've got some research.
Thank you, Jeremy. I'm going through and skimming through the questions. I believe this one has been answered already. What are the advantages of video lecture compared to the book? I believe Jeremy mentioned that it's two modalities and they cover the same thing, so it's beneficial. The best way to do it is to do both. Is that correct, Jeremy?
Yep.
Awesome. I have an idea. Is Keras an API with TensorFlow 2x? Is FastAI same for PyTorch? I believe that's been covered quite a few times, but Jeremy, feel free to cut me.
So
yeah.
So for those not familiar with FastAI, the FastAI library, yes, it plays a similar role to Keras in TensorFlow. It's a higher level API that lets you worry less about the boilerplate and focus more on what you're trying to do. It's got a very different design to Keras. We actually originally we taught Keras in the early days of the course, so I'm very familiar with it, and I thought it was really great. I'm very familiar with the benefits of it, but also very familiar with the warts of it. And one of the things I found challenging was it was a bit difficult to dive under the covers and really change everything. And so FastAI has an extremely decoupled and layered API, which is designed to be really useful for researchers to allow them to change absolutely anything. And also designed to be useful for practitioners in terms of it's very easy to focus on the part of the code which is relevant to you and not have to worry about all the rest of it.
Thank you, Jeremy. Next question that we have from Surya is it important that we go through the machine learning course of FastAI before the second part of the course?
Oh no, thanks for the question. This course, the new version of the course we're doing now, actually incorporates the machine learning pieces you need, so you don't need anything else.
Excellent. So the 2020 course is already covering that. That's awesome. From questions from Aditya about the future of FastAI, what are the new things coming in FastAI, and when will we have TPU with FastAI?
So Aman and I are working on the TPU stuff right now, so feel free to nag him if you want it more quickly. But we've been waiting until the TPU VMs have come out of alpha for publicly available use. That just happened last week, like a few days ago, actually. So now that they're available, we can provide that. There was a previous way of using the TPU with PyTorch, but it was extremely unoptimized, and I don't like to provide ways to do things when I don't think it's the right thing to do. So I didn't provide a TPU approach before, because I just think if you're going to use TPUs, you should use TensorFlow, because that was the only one that had the ability to go fast. But now that the VMs are available, we are going to release TPU support soon-ish. In terms of the new things coming in FastAI, Aman, if you could open up the FastAI repo, so just go to fastai/fastai. And then, great. And then click on projects. So if you want to go and have a look at this project, you can see some of the stuff that we're working on there. The key kind of direction for this next version will be to massively leverage the two brilliant libraries that now exist, TIM for computer vision and Hugging Face for NLP, and to provide really fantastic integration for those libraries. That's the main thing that will be kind of the focus of the next version of FastAI, but there's other things you'll see in that project as well.
Thank you, Jeremy. How to learn meta learning. Oh, sorry, it's 2 p.m. Jeremy, conscious of your time as well. Would you have maybe a few more minutes just to answer
Let's do 10 more minutes.
Yeah, excellent. Thank you, Jeremy. Question from Saurav, how to learn meta learning, meta researching as mentioned by Jeremy.
So one thing that's really, actually, you know, there's a really great site maybe you can go to for us, which is supermemo.com. Yeah. So this would be a great place to start. This is from a researcher named Peter Wozniak, and he has software, but that's actually not the main thing I wanted to show you. But you'll also find on SuperMemo, there's a huge number of resources around methods that he's studied for learning about learning. And so that would be one good place to look. Another way would be to look at the kind of methods of the memory champions. There's a really great book called Moonwalking with Einstein, which I highly recommend. And that's all about the techniques used by world memory champions. And it's not only interesting for memory, but it's also fantastic in really showing you how, yeah, that's the one, the top Amazon one there, how the things that we think of as kind of hard-coded, that there are people who are smart and people who are dumb, or people who have good memory and people who don't. It actually turns out that's on the whole not true, and that these are all skills that you can learn.
Thanks for the good question, Saurav. Kurian is asking, hi Jeremy, how many hours do you try to learn new things outside of your work? Is learning multiple programming languages useful for a deep learning practitioner?
Yeah, learning multiple programming languages is such a good idea, particularly because the Python community is extremely insular. So there's a lot of very opinionated things in the Python community that are wrong. So if you get, you know, into JavaScript or Lisp or Kotlin, you know, you'll learn all kinds of interesting new things. How many hours do I try to learn new things outside of your work? I've always tried not to separate out my work from non-work too much. Because like I always try to work on things I find interesting. You know, I spend a lot of time reading about stuff which I guess technically you could call work. Like one of the things I don't do is I don't watch any TV, and I don't play any computer games. I mean, it's fine if you want to like literally decide I want to learn a lot about computer games, then play lots of computer games, right? But that's not something I've spent time with. But you know, I've recently started trying to learn some chess, so I spent time, you know, studying chess. I recently, I don't know, there's always kind of things I'm interested in learning about, and I could, you know, I try to have something, you know, on my Kindle, on my phone, whatever, at me with me all the time. So anytime I'm like waiting in a queue, I'll be reading, you know. So I don't know, it's all kind of out of work in a sense.
It's really exciting to hear as someone, yeah, it is really exciting that, and these are all really good advices. Question from Kevin, has anybody confirmed that Jeremy has invented a time machine? Same question from my side. Question from Abhay, doing so many things, that seems like a lot of distraction. How do you get your focus back, Jeremy?
Yeah, that's a good question. I only do one thing at a time, and I only can do one thing at a time. So I do one thing, and then I go and do the next thing. And so I think it's like difficult sometimes for the people I work with, because sometimes I do kind of go dark for a month. But then I find people are surprised when I then come back and finish the thing I said I'd finish. So yeah, I think that's the main thing, is like I do my best to polish off each thing as well as I can, and then move on to the next thing. And I think the other things just burble around in the back of my mind, and so by the time I come back to them, my brain seems to have figured a few things out, which is nice.
Again, question from Kevin, do you keep the 4 hours in a single block or break it into smaller blocks?
Generally 2 blocks of 2 hours.
Question from Alrisa. I had the wrong idea that this was a paper reading group in deep learning with Jeremy. Always a fan. Very exciting to be here. and looking forward to the next 3 weeks. I've been working a full-time job and finding it difficult to keep up with the latest DL research. Can you recommend your top go-to resources in order to get daily, weekly research paper summaries and discussions in computer vision? Everybody follow Jeremy on Twitter. That's the one thing that I wake up and do have lots of news. But Jeremy, please take this.
Yeah, I use Twitter. And then if I want to dig more deeply into something, stuff like Archive Vanity is quite useful. Semantic Scholar is quite useful. But I don't think it's possible to keep up with the latest DL research, even in a subfield. So instead, just, if you follow the right people on Twitter, and you can do that by looking at my favorites on Twitter and then just go through and follow anybody who seems you see there's posting interesting stuff. That will generally highlight the really obvious big things that come out, and then follow your interests by looking through citations. And yeah, as I said, Archive Sanity is quite helpful for finding similar papers, stuff like that.
Yeah,
and don't be afraid to ask people on Twitter as well. Like, there's always quite a bit of noise on Twitter. So when somebody asks you an actual well-researched, thoughtful question on Twitter, you'll generally get a thoughtful response. But just make sure it's that you provide as much context as you can. So if you have a computer vision question about some issue around ResNets or something, well, I'm interested in this question, I tried to solve it and I looked at this paper and this paper, but I found I still had this issue, really show your research, show what you've done, and then ask the question. Hopefully you'll find you get some good answers. If you don't, often that means that nobody else knows the answer to your question as well, and that would be potentially an interesting research field then.
Thank you. I just want to quickly add my first 1,000 people I followed were from Jeremy's list as well.
And the way I got by the way, one of the many silly little projects I've done, the way I got my list of people I follow was I wrote a little script with the Twitter API. Obviously, I did it in a Jupyter notebook that went through all the people I had favorited for the last couple of years, and anybody I think I'd favorited like 2 times, I automatically followed them, and then anybody else I automatically unfollowed.
This is one of the projects that you said you'd like to take the mundane away and make it more interesting.
Yeah.
Will all the 20 weeks be available on YouTube? Yes, they will be. Any links to practice Python?
I'm not the right person to ask about that. I think you should probably ask, on the forum for this session.
I'm a non-coder. Most of my career went in support, and it's the same. Yeah, sorry. Shank, what's the best way to practice deep learning?
Yeah, I think just what we talked about today.
Karthikeya, I built my computer vision startup entirely with FastAI.
Awesome.
That's the startup. Trying to build a team and probably raise a seed fund. How should I move ahead with this?
Okay. Can we see the startup, please? Can you go to that link? Let's check it out. No pressure.
Hopefully it's not a
spam
or spoof.
Okay. Cool. So I'm planning to run a startup course, maybe kind of early next year. So can you go back to the question? I can't remember exactly what it was, but yeah. Oh, yeah. So for raising money, the main thing is to make sure you've got a good working product online, that you have some customers, and preferably that you have some people paying for it. Generally, if you can show investors people paying for something that you've built, that's a pretty, that should generally be enough to get you to raise a seed fund. You should also be able to show the investors some guess at how big the market is for the thing that you're selling, so that they have a sense of how big it could get. And generally, for trying to build a team, most successful initial teams are built by kind of people mining their networks, the folks that they've come across in their life who they thought were pretty smart and nice to work with. That's, generally the early teams. So people are yeah, their own friends and their own network. All right, so that's 2:10.
Okay. Thanks very much, Jeremy. That's all the questions that we can take, and sorry for everybody else whose questions we couldn't take. I do want to say thank you for everybody for joining, and again, massive thanks goes out to Jeremy for finding the time and joining us. I'm sure we've all benefited from having Jeremy here. So thanks, Jeremy, and see you, everybody.